All right, so what we're going to do here is it says read through it. We'll read through it first to get a little visual here. It says students are competing in a 4 kilometer relay race. So it's a total of 4 kilometers, which is indicated by the number line here. All right. And then there are 10 runners. So we're splitting this up amongst 10 runners. All right. So what we're going to do is we'll break this into, we can see that each runner runs 2/5. So a full kilometer, which is right here, we're going to put 1, 2, 3, 4, and then this will be our fifth one. So 1, 2, 3, 4. This is 5. 1, 2, 3, 4. This is 5. 1, 2, 3, 4. This is 5. So in between each number, you should have 4 dashes as close as possible. So in order to know where to circle this, to visualize it, well, each one of these is a fifth. This is indicating right here that each runner runs 2/5. So each circle should hover over 2 of these. So you get 2. Here's another one. Here's another one. All right, so these all should look like this, so that there's 1 dash in between. There's another one. We have that. All right. All right, and then this over here indicates that there's 10 runners. All right, so make sure that you're drawing this all in. And if you look, each one of these circles in total equals 10. So that's that portion. And then for B, it states use multiplication or division to describe your work on that number line. So what we did is we let me do this here, okay? So let's go back. Whoops. So what we did is we, starting at 4, we drew circles that each represent 2/5. Then we counted the circles that we drew in the number line. All right. All right, so what you're going to do from there, this should go in for part B, so make sure that you take a minute and write that in. All right, this is all going on page 30. All right, so everybody should be on page 34 of their consumable notebook. We're looking at the one that has the picture of the piece of wood at the top, so please follow along.
How can you represent division of fractions? Think about this question during the lesson. Mr. Roberts plans to use pieces of wood that are each 3/4 foot long to build a set of shelves. How many shelves can he make from a board that is 3 feet long?
Think. How many 3/4 are in 3?
Here is one way to solve the problem. First, write 3 as a fraction with a denominator of 4. How do you write 3 as a fraction with a denominator of 4?
All right, so basically what they're asking us is which one of these would simplify to become 3 over 1 or 3. So it's not this one that you would think. This is the only one that reduces to be 3.
You can write 3 as 12/4. Think of division as repeated subtraction. Why is 3 rewritten as 12/4? How many 3/4 are subtracted from the 3-foot-long board until 0 is reached?
Well, let's take a look. We can see here we have a 3/4, 3/4, 3/4. So it looks like there may be 3 of them, maybe 4. Let's take a look.
3 is rewritten as 12/4. because having fractions with a common denominator makes it easy to subtract. 4 3/4 are subtracted from the 3-foot-long board.
So that's your bottom 3/4 here, the ones that they're taking away. 1, 2, 3, and 4. 4 times.
Until 0 is reached. Mr. Roberts can make 4 shelves. How can you check whether your answer is reasonable?
All right, well, the way to check to see if your answer is reasonable is just to go backwards. If we subtracted 3/4 from one another 4 times, we could add 3/4 4 times, or we could multiply 3/4 by 4.
To check whether the answer is reasonable, you can add 3/4 4 times to make sure it equals 12/4 or 3. Here is another way to solve the problem. Use a number line to show 3 feet. Divide it into 3/4 foot parts.
All right, so what you could do is, if you look in your book, we can see that it's written as the circles here. So if you take a look, you can measure it that way, all right? Now, let's go on to the try it. So it says a board is 6 feet long, all right? So if a board is 6 feet long, all right, we can know that our last number over here is going to be 6, all right? Because that's the total of what we have on hand. All right, so what these other ones would indicate is this is 1 foot, obviously this is 0, 2 feet, 3, 4, and 5 feet, all right? We want to see how many 2/3 we can get into each one. So if we just look at the 1 and break it into thirds, well, you have this, this. Those are 1/3, 2/3, 3/3, which is a whole. 1 and 1/3, 1 and 2/3, 2. 2 and 1/3, 2 and 2/3, 3. 3 and 1/3, 3 and 2/3, 4. 4 and 1/3, 4 and 2/3, 5. 5 and 1/3, 1. 5 and 2/3, and then 6. So we'll do what we did for the warm-up. We're going to circle 2/3. So you're looking like what we had before, where there's a 1 in between. All right. Keep going. And then at the end, we count our circles. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's do 6 divided by 2/3. This is our mathematical way. On top was our visual. Remember to keep this, change this to multiplication, and flip this upside down. Well, we should get 9 as an answer, so we cross cancel 1, 3. 3 times 3 is 9 over 1. Same thing, it's 9. So all of this should be written in that we did here. So take a minute to fill that in on the bottom of page 34, all right? And then the convince me part is why the number of pieces can be cut from the board greater than the number of feet in the board of the length. Well, that is because each one is being broken down. All right, so just be concerned about writing this in for your try it. Okay, so we got 9 pieces. Should have all right, let's look at example 2 at the top of page 35. They give you a picture here, but I'll explain it. It says, how much cake will each person get if 3 friends decide to share half of a cake equally? So it has 1/2 left. They sketched it out in orange there. And then you're going to break that into 3 equal parts as well, so making your overall 6. And then if only one person is getting each of that, it's going to be 1/6. So let's take a look at this one here, where it says to make a diagram. All right, so let's sketch this out. We're going to draw a rectangle again. All right, so for the beginning 2/3, and we'll do this mathematically afterwards, after the drawing. We have 2/3. So this is what we actually have here. All right, and then the 4 indicates of what we're going to cut that into. All right, so let's break that whole thing into 4 parts as well. All right, and then where we cross over is right here. So we can see that that's 2 out of 12, which is the same thing if we reduce to 1/6. Now what we can also do is let's erase this, is if we just do it mathematically, which we'll probably choose to do rather than drawing a diagram, but just to give you a visual of how division of fractions works, I'm going to go through that right now. So remember, we have 2/3, that's division. This should become 4 over 1 because we can't multiply or divide by whole numbers. We keep this, all right? And then we change this to multiplication and we flip this. So keep, change, flip. We can cross cancel. We get 1, 2. 2 goes into itself once. It goes into the 4 twice. Multiply across. 1 times 1 is 1. 3 times 2 is 6. So this would be our amount that we would get, 1/6 of the entire. All right, everybody, you should be following along on page 35 of your consumable notebook. We're looking at example 3 here, and then we'll try it together. It says you can use what you know about dividing fractions to find and use a pattern. Look at the division and multiplication sentences. Find and use a pattern to solve 4 divided by 2/3. So the pattern shows that when you divide by a fraction, you get the same result as when you multiply by its reciprocal, meaning that you multiply by its flip. So that's what the chart's indicating here. They're just doing the keep, change, flip, showing that, you know, if you say 8 divided by 4, you get 2. It's the same thing as saying 8 times 1/4. So we already know with our elementary type of division, using whole numbers, 8 divided by 4 is 2, 6 divided by 2 is 3, 5 divided by 1/2 is 10. All these things are just re-emphasizing that. So what you would need to do is rewrite the problem as a multiplication problem using the reciprocal or the flip of the divisor. Okay, so that's what they're expressing here. And then if we look at the try it here on the bottom, all right, so we have 8 divided by 3/4. So for the first box, we should know that we're going to take the flip of this, which is 4 over 3. All right, and then we just multiply across, so 8 times 4 is 32 over 3. So we could say that we have 32 over 3, but being that we don't want to leave these the way they are, you divide the bottom into the top. Whoops, let's see here. The bottom into the top. 3 goes into itself once. All right, cannot go into 0. So what you're left with is 10 2/3 would also be your answer. All right, so please make sure that you have that written in for page 30.